Well, hello everyone. I hope you're having a wonderful day. I'm going to go ahead and open us up in prayer, and I'll give you a sense of the things that we're going to be covering today. So, dear Heavenly Father, Lord, I pray that you would be working in the lives of each of the students in this course. I pray that the material will be clear, that it'll be interesting, and it's going to help them get the job of their choice or opening the business of their choice in their future. Pray that you would help them in their spiritual formation, Lord, that you would help them to see the value as they're getting a chance to study scripture, to cherish that in their heart. Help them to be able to drive the theological concepts that we have from that, and give them interesting and creative ways for faith integration. In Jesus' precious name, we pray. Amen. Okay, well, what we're going to be going over today is I'm going to just briefly talk about stuff that's in chapter 13. I'm going to save that for Monday for going through it in detail. I want to spend a little bit of time talking about the Arduino unit, and so I'll talk about that, but also just want to get a chance to get a little bit more insight into what's going on with instructions and try and tie some of the things that we have been exposed to already to help out in that regard. So, like I said, I'm going to go over chapter 13 next Tuesday, but I'm just going to handpick a few charts here, just give you a precursor related to something that's a lower level um, that we're going to be thinking about. And so in our Mars MIPS emulator with our assembly language programming, we're starting to get a chance to be thinking about, well, how do we actually code an operand and the values that it's supposed to be doing an operand, feed that to the CPU. And so what kind of formats would that have? And so this just gives you an idea of, for an x86, they have a variety of different formats for how they look at different numbers. And so just to give you an idea, so x86 architecture, the op codes, the operands, the length of the commands are not always the same. They're not like 32 bits or 64 bits the way it is with the MIPS or the ARM architecture, and those are related. So I just wanted to make a quick point about that. And so we're going to go over this more on Tuesday. And so just a reminder of what we have there is, what are the machine instruction characteristics? There has to be an opcode and the things that you're supposed to work on it with. Then we can have the different types of operations that are there. There is distinctions between the x86 and the ARM data types, and I'll get into that a little bit as we go through our lecture today. Also, just want to make sure that I allow for time for individuals if they want to be sharing about some of the things that they're coding. So, and developing with your projects related. So, this is a chart that I showed previously, but what I wanted to start to give you an idea. And so here is the name of the instruction. You would have this opcode, and then you're going to have other variables. What's going to be fed into the registers. Remember, I was talking about the arithmetic logic unit. You have to have two inputs. Then there's control lines that tells what you're going to be doing with those two inputs, and then it has that information is sent to an output. And so here you can see that there's 4 different types of command variants for add. And so you can see the opcode for an add is 100001. So it's 6 total digits. And so here's a variant of that. And so the opcode is different for that. And so here are the 4 different opcodes when that's read into a CPU. And then this is routed to an arithmetic logic unit to do an operation. It knows that these are the things that you would want to be doing. There are various types of branching. So you have branch if equal, branch if greater than, branch if less than, or branch if it's not equal. And so basically you're comparing two registers, and then depending on what command that you're sending, it's going to do something. And so you have a simple way of doing decision making. You don't have an if loop and a while loop and all these kind of things, but you have this. This is sufficient for what we want to be doing, to have the general characteristics of what you would be finding in a higher level language, but this is a lower level. So we have a regular type of operation: add, subtract, multiplication, divide. We can have branching. We can have load. We have LW, load word. There's various types of loads here, so there's some variance there. We can have things like and, so we can have logical operations, Boolean operations, and or. And so those are just some things that we're getting a chance to be thinking about there. Are you guys tracking with what I'm trying to have you think about here, as we're getting close to a point where we're talking about commands? You're doing your MarsMip emulation, and so that's an important part. If you guys want to give me a thumbs up if you're tracking, I see some folks that are tracking with what I'm trying to convey there, so good. Well, let's continue on this track, and this is a short handful of charts that I put together that gives us a chance to be looking at how does a MIPS assembly language, what does it look like as compared to an x86? And so I just have a handful of charts to set up two major charts that I'll show at the end, and you'll see some similarities and some differences between these two. First of all, let's look at a couple of CPU architectures. And so the two general categories are complex instruction set computing and reduced instruction set computing. And so this just gives you an idea. For example, for MIPS, there's 32 registers. For an ARM, there's 16. For the x86 64-bit, there's 16 registers, and so we can see that there's a variation between those. I'm not going to go over everything here, but you can see the general dates of creation. So here we can see for the x86, Intel was first at the gate in the 1970s for a 32-bit architecture. AMD actually got ahead of Intel, which of course Intel wasn't too excited about, and so they had a 64-bit processor before Intel, but Intel has continued to be able to navigate the market, and so that's just a story I won't get into detail, but we do have two manufacturers. And so what are these being used for? So x86 architecture has largely been used for PCs, and so there's other things, the original Xbox. For the ARM architecture, it's been the iPhone, the iPad, and now with the Apple Silicon, even their laptops are now using the same ARM type of processor. So all of these fall in a general class. We're looking at the MIPS, and so this has been something that was created by Stanford in the 1980s. The PowerPC was a processor that was designed and built by IBM before they stopped building CPUs. And so this was something that the Macs used for a while. And so then they went to the x86 architecture, and now they're using an ARM architecture with Apple Silicon, with their own brew of doing that type of configuration. So you have load, you have store, you have these kind of things that you can see that there's a little bit of variation in the nuances for how these are done. And so MOV is how it is spelled out in an x86. For MIPS, load word. And so that's just gives you an idea of a comparison of those. So this was just a sample. I'm not going to go over this, but this in our textbooks, we get a chance to see some various architectures, and this was an attempt when I was putting these charts together to show you a fairly current type of architecture that Intel is doing. Okay, well, the x86 64-bit has almost 1,000 commands. So you can see this complex instruction set. There's just tons of them that are there, and it just goes on and on and on. And so this is just showing a bunch of them here over 4 slides. And I just highlighted, look at this. This is like for move. And look all of these variations of move that you have. And so that was just like an example of one of the things that we saw here, how to load a constant. And so that's the nomenclature that they use for that. So then I'm just going to do this hello world and compare them between the MIPS version versus the x86. And so I'll start with the MIPS since we've already gone over this in our Mars MIPS emulator. And so you have these directives .text, .global, .data, and .ascii. And so basically what we do here, if we wanted to have hello world, we have to have all this overhead. You have to have a main. And so that's something that we have here. We have this load. So we're loading a value, load immediate. So we're loading a number into a register. And so this is the value when we load into this register V0, that's going to do a system call. We're loading into a different type of register for data, the hello world, and we do a syscall. And so what this is going to do, it's going to take this value that we have here in message, and it's going to put it to the console. And then we have another load immediate for 10. 10 is a syscall for exit, and we do that, and we have a simple way of doing that hello world, getting it to the command line. Well, with an x86, here is the way that they do it. So basically, we have 2 commands like we did on the last one. So the first one is having it print out to the console. The second one is having a clean exit. And so these are the commands that we're putting things into the right associated registers that is going to take this. And so here we have the length. And so we have this string. And so this is computing what the length is of this string is. And so that's put into this register. The message, hello world, is put into another register. Then there's these other registers that are used to help pass on what is going to be going on. So this is where the output is going to the standard output or the console. And we're going to do a system write. And so we're going to be writing the contents of that to the system console. So we call the kernel, and it's going to print it out on the console. And then we exit, and we completed that command. Now we're ready to do another command. And so we're using 2 registers here. We used 4 registers for this first command. And so this is the call that we're going to have an exit. Then and so we have this other one here. This is the system exit number. Then we do the call to kernel, and we execute that. So you can go back and forth, and you can see that there is some differences between these 2. And so these were ones that I wanted to compare. So you guys tracking? We're not doing x86 assembly language in our Mars MIP emulator. We're doing things in the, we're doing it Mars MIPS. We're not doing the x86. Okay, you guys tracking that? Okay, so what are the points that I've tried to make so far? We are moving into this area where we're now want to be thinking about how we're going to be having the the software that's going to be communicating with the CPU. And so there's certain formats and structures of what we need to do that. The numbers have to be in a certain format. The commands have to be in a certain format. So here we can see the opcode, just an example of that. And everything fed into the registers have to be in a certain format. And so we have to pick a particular CPU. And so we're picking the MIPS CPU for what we're doing here. And I tried to give you just a brief comparison of a couple different CPUs that are out there. Okay, so like I said, we're going to get into this next Tuesday. I'll go through this in detail, but we'll have 3 chapters where we're going to be thinking about instructions and how we communicate the way a CPU thinks. And so with the brief encounter with our assembly language programming, you're going to get a chance to have some fun doing that. Any comments or questions on what I shared on that?
I just have like a quick question, but it's on the project, so I don't know if I can ask this.
Yeah, sure.
So because for my project that, or for my second program that I want to do for the project, I was wondering if I can, uh, because like, okay, so for my project, it's the Sensormatic system, so it's like creating doors.
Mm-hmm.
So I kind of want to implement that to my second design I did for the first project I did, which was like making 4 doors and then like comparing their results into a final result to check if the system's online.
Yeah.
So I was wondering if on the MIPS assembly language, if there's a way I can compare like uh if I can use 2 branches like the BEQ commands and then like implement it into a final result and check if like be able to check if like all the doors are open or closed. Um, but it'd also be possible to use like the AND command as well. And I was wondering like how would I use the AND command?
Well, the AND command, this kind of gets into more specifics about the actual format of what is required. And so the short answer is, yeah, you can do that. Um, um, And I think what you want me to do is to try and help you walk through that. And why don't I do that towards the end, after I just go over a little bit more material? Nathan, is
Yeah,
that
no problem. Yeah, yeah.
okay? Because I think others would find that useful as well. And so I'll pull up the Mars MIPS emulator in just a few minutes. Okay, I'm going to keep doing this, but let me go around the virtual room. Has everybody ordered their Arduino kit? That's to be something important. Um, I don't want to embarrass anybody, but please get that because we're going to be starting to work on this fairly soon. And so this is going to be the first encounter that I'm going to talk about the Arduino. So um, the so I've already talked about how we have a rough relationship between the digital logic, the assembly language programming, and what we're doing in the Arduino. And so what this now is trying to give us a chance to be looking at the cyber physical environment that the world that we live in. We live in a physical world, but because we're programming, we're also thinking in terms of the cyber of how we actually make that happen. And so let me give you an idea of some of the things that you're going to be finding in your kit. And so I recommend that you get one. Is what's called an Arduino Uno. And the link that I have in Canvas is that. So this is what the actual unit looks like. I'll have a picture of this that'll be a little bit bigger, but you plug in your USB connector. So this is how you connect to your computer. And then you're going to be having all these different things that you can stick in one of these wires, one end in here, and then you can stick another end into this wiring board. So here's a USB connector, here's the wires, here's the push buttons, here's the various kind of LEDs that you have, and there's some specialized sensors that are in the handful of items that you have. And then you have a lot of these things that for some, the engineers will have more familiarity with these. The computer science folks may be kind of scratching your head, but these are called resistors. And the way I like to be thinking about that is when you turn on your faucet, the more that you turn it on, the more water that flows. And so the resistance for the water to flow is less. And so you're reducing the resistance. This is the kind of thing that now, instead of doing it with water, you're doing it with electrons, the things that are forming the current. And so that's probably enough to give you an idea in general what we're thinking about what a resistor is. And so this is a blow up. You should have something like this, a piece of paper in your kit that will be describing the various elements. And so here is kind of something fun. I can be showing you, I won't show it today, a photoresistor. And so when light hits it, it reports out a value that you can read in from the Arduino and a console that's on your computer, and you can either get a number or you can have a graph. And so there's different ways you can be seeing that. So that's something that's kind of interesting that we can be leveraging as a sensor. So this is a light sensor. There's other things that, like if you're tilting, you can have that. You can have a heat sensor. And so if you put your fingers on it and it gets warmer, it's going to change. And so some kind of, not quite the same as this, this photodiode, this photoresistor, but that gives you that. Some may just have a single LCD or LED digit, so you can have 1, 2, 3, 4, 5, 6, 7, 8, 9, or 0 displayed on this, or you may have one that has multiple digits on it. That's something that you have. Here is the breadboard, the wiring board. This is also fun. This is actually has, it's called an RGB light emitting diode. And so you can have red, green, and blue. And by the combination of those colors, you can get a lot of different colors, like your TV at home or your monitor that you have on your computer. It actually has 3 different diodes of different colors. And so this is how you're generating the various colors by how much, what intensity does each one of those things have. This is a blow up of the actual Arduino Uno. And so there's some interesting things that are on here. There's actually, instead of having a CPU, it has what's called a controller, a microcontroller. And so this is the workhorse microcontroller for managing the inputs and outputs, and for that. And then there's also another microcontroller that this is for the interface with your computer. So this is an I/O card that speaks USB. And so this is how you're communicating directly with your computer. And this other side, this is how you're communicating with your breadboard. And so this is a larger breadboard than what we saw in this earlier picture. You may get something that's this size, or you may get something that is a little bit larger. And so these lines going like this means that all of these along this here are behind, they're all connected together. And so there's a wire in the back that connects these together. So if you stick a wire in here and then you stick another wire over there, they actually have a physical connection. So here, these are all the same. They're all connected down this line. But where the components are, now all of these 5 pins are all connected together. So say I put a component in here, and then I want to have this connection going to my Arduino, and I need to put it in a specific place. That is how I'm going to be making one of those connections. So let me see if people are tracking with what I'm conveying here. This is going to be some of the how-to that we're going to be using when we're creating something with our Arduino kits. Is that, you guys tracking?
I'm a little bit confused. So we put like I guess we use like the wires, the
So you
little,
put this wire and you put one end, say I'm going to go to this pin here,
mm-hmm,
and then I put the other end of that wire onto this board here.
mm-hmm.
and then I have a component or an LED or something like that that's connected here. And then I have to put some other stuff to make it work. I'm going to show a picture of this in a second, Nathan, and that may be helpful.
Okay.
Okay. So I'm not going to go over these now, but these were just a snapshot of the various types of things that was in one of the first Arduino kits that I had. And so you have different kinds of LEDs, the three colored LED. Here is that photo conductive cell. And so a light emitting, instead of being a light emitting diode, it actually can sense light. This is another thing that's on there, a shift register. We talked about that in recent lectures. And so this is starting to get a little bit clearer to you what that is. But for the most part, I recommend that people don't focus on using that for now, because that gets a little bit more complicated. Here's a push button. So when you push it down, it makes a connection. When you let it up, that connection is no longer there. This one tells you if it's beyond a certain angle, it's going to say, okay, it's tilting. And so it's going to give a different response. And so that's something that you're going to be able to see. Plus, there's lots and lots of resistors. And I'm not going to go over that. So here are two ways of showing this design. So for those that are engineers, this will look more familiar to you that you've had to see this. And so this first thing here, this is the Arduino kit. Now these are specific pins that you're connecting things to. And so you have one wire here, here's this red wire. You're going to be putting this on your breadboard. And so you're going to stick a resistor in, and then you're going to be hooking this up to an LED, and this has to go back to ground. So when you power something up, you have to have where the voltage is, and then you have the other end that's going to ground. That's how you're able to close the circuit. Well, the engineers are probably pretty familiar with this, but for the computer science folks, this is probably more helpful. And actually, in general, I think for everybody, this is how you would hook together this tricolor LED, red, green, blue. You just need to make sure you get the pinouts correct on this. You have these resistors connecting to this LED. And then so you have ground, and then you have three other inputs. One drives how much red's going to go in, one that's going to control how much green is going to go in, and one that's going to control how much blue is going to go in. Does that make sense? You guys tracking this? And so this would be something that would be fairly easy to replicate, just looking at, you just need a handful of wires to put this all together.
Professor,
Yes.
so we just need to like, I guess, make sure like the lines are all connected to the same line, like with the resistors and like the red green wires, they all have to be connected into the same, I guess, sort of line to make sure that they all work because they're all like connected.
Yeah. Yeah. And so this is going to be, for what we're doing in this project, as much of the hardware that we're going to get involved. It can be a little bit more complicated. Maybe you might want to push a push button here, put in other types of monitoring LEDs. And I'm going to be coming back to this, but this is my first time of showing you some information about the Arduino. And for some, it's brand new. And so I'm just slowly trying to introduce this. So don't worry, Nathan, this isn't the last time we're going to talk about this, okay? So I'm just trying to give a high-level introduction. So this is the hardware side. Now this is the software side. And so this is looking at the Arduino IDE, Integrated Development Environment. And so this code is a little bit complicated, so probably not something to start out with. And so this is the way that it would look in your IDE. You're going to have to scroll up and down to get all of it. But in general, there's a couple things that we have as you're defining what pin you're going to be connecting to. And so that's one of the things that you have. And so here are blue is 3, green is 5, red is 6. So 3, 5, and 6. You can see that this is where I'm calling out these specific pins that I'm going to be using for that. And so this type of project is basically it's going in one direction. You're sending information to the Arduino that then sends voltages to these 3 different inputs to this RGB LED, and you're going to see that this LED is going to change color, and it's going to go from one color to another, and it keeps repeating and repeating and repeating, and so that's what's going on here. So, like I said, this is just a first blush introducing this, and I'm not going to go into this in too much detail. This is maybe a little bit more readable version of that code. And I actually include, this is just a screenshot of this, but this is that circuit with a smaller breadboard. So probably similar to what you have with your kit. You plug it into your computer. And so this is hooked into the Arduino on this side. We see that there. And then all of these wires that are part of the kit, we can see that we're just having to hook in wires on this side. And so there's 4 wires that are going from the Arduino to the breadboard, and it's going to cause this to turn on each one of those a certain amount, depending on what the signal is. So any comments or questions on this?
What's the black wire for?
This is ground. This is where something that it's going to be more familiar for folks to be familiar. The engineers are going to be more familiar with this. To have a circuit so let's say I have 5 volts here. And then I have ground down here. And one of the ways this is in terms of schematic ease, it looks like this. And so we have something here. And let's say I'm going to be hooking up an LED, which is a type of diode. And so the thing is, well, I can hook that up to ground. And if I did this, it's going to burn out this LED because there's no resistance. This is a low resistance. You can see that it's like it's an arrow here. This is the direction in which the current is easily going to flow, but it's not going to flow in the other direction. And so this is the reason why you have to put in one of these resistors here to limit that flow, because the diode itself is not going to be helping you do that. So this is why we need a ground. So that's this black wire. And we're using nice colored wires here to help us remember which one that we want to be utilizing here for what color this is representing. Okay, does that help? Did it help, Nathan?
Yeah, it helps. I mean, what I don't see is that like there's no resistor on the black wire, even though you said a resistor has
These
to.
are resistors.
Oh yeah, no, I see that. I was just okay. I thought you were talking about the black wire having the resistor.
No, this is actually going from this. This is like the maximum voltage, and so this is like going from here. That would be this 5 volts. It's actually going to go from 0 to 5 volts. It's going to go up and down.
Yeah.
So that's, so I put these in the opposite order. I could have put the resistor up here versus down here. So the resistor, and you have the LED. And so this LED has the ground is shared among all three of these LEDs that are in this larger package that we can see there. Does that help, Nathan?
Yeah.
Okay. Any other comments or questions? People tracking? Give me a thumbs up if you're tracking what I have here. Okay, get out of full screen mode here. So those are a couple things that I just wanted to make sure that I introduce. So how is it going for you guys with the Mars MIPS emulator? Have you all been able to start to get things coding and getting some success from that? Can I get some feedback on that? Okay. Some of you responding. That's that you're making some progress that way. That's good. So I'm gonna open up the Mars MIPS program here, and since we're finishing up in terms of the lecture portion of doing an introduction to this, I do strongly recommend that while we're doing this here, that you open it up yourself, and so you can be seeing how this would work. So we just went over the hello world, and so this is exactly what we saw that I showed here. So let me compile this. And now we can be seeing that for LI, what is the ops code that's related to that? Fortunately, we can just go at this level. We don't need to be thinking about the ones and zeros and the various ways that we can report it. What is the way that we would be reporting this? If we instead of it wanted to look at ones and zero, what's another common way that we consider numbers from the point of view of how a computer would see them? Anybody remember the name of that?
Hexadecimal?
Yeah, right. So here is the hexadecimal values. We can go from back and forth. We can have the hexadecimal for the address. So these are some of the things that we can be doing within the Mars MIPS emulator. So one of the things that Nathan was asking about was a logical function, and I don't think I have anything logical function in my sample programs. I didn't. So I won't be able to, at least off the top of my head, come up with a specific example that I can pull up for that. And I'll say next time or something we can go through this in a little bit more detail. But this is where what you're mentioning for the and. So there's two possible ones that I could use. there's a regular and there's also a and immediate. So let's look at the first one. So it's a bitwise and it sets this register to be bitwise and of these two other registers. That probably would be what you would want. And so if you're having just one bit of that register, that's fine. And so if you have, if there's one in register, the first one, and then one in the other register, then it's going to give you a true or false. And so this other one is a bitwise and immediate. And immediate means that you're having like a number that's included. So it sets a bitwise T1 to bitwise and T2 and 0 extended 16-bit immediate. I'd say just focus on this first one, Nathan, because this is fairly straightforward. And I think this other one just brings in more complexities. And so try and load values into two registers and then execute this command. So let's see how that would work. And so I'll open a different program, one that we already went over. What was this one? Oh. So here we're initializing a couple of registers, T1 and T0. We're doing first an add immediate. So we're adding 1 to register T1 and we're putting that result back into T1. So you can see that we're starting to manipulate registers. And so this would be a good thing to do is first set to the contents of your registers to 0 to make sure that you don't have anything anomalous in there. And so instead of doing add, what you want to be doing is doing this and. And you can define the registers. And so we can be having it T1 and T2. So the output is T1, the inputs is T2 and T3. So that's how you would be doing an and for those, comparing those two things. Does that help, Nathan?
So wait, the and command, like, so it sets T2, so it gets like, it sets like the command for T2 and T3 and then puts it
Yeah,
into T1.
right.
Okay.
And this is one of the things you have to be mindful of is the specific syntax. So maybe it would have been more intuitive the way we think that you would have the last register, the output register would be the last one listed, but it's actually the first one. So that's one of the things you want to be.
Would it still work if I put like say, because I probably would use like T1 and T2 into like a register, like when I want to open like or create a message for like the two doors and say like is door one open or is door two open, I'll say like I'll put that into T1 and T2. So then it's like if I want to create like an and command for them, do I just set it to T3 getting that result?
Well, I don't think you want to do a bitwise comparison of asking characters. And so you can have a couple of things that you could be doing. So you can be loading the values of what you want in two registers, and then you have the actual contents in two other registers, whatever values that you want. So say like um, setting a 0 or you could also do an IO example where you're letting you put in from the console, but that would probably be like, remember I said there's 3 subprograms. So maybe first is just don't have an IO, but just have it hard coded. And then you get that working, and then you can actually do the IO as the next step. Is that helping, Nathan?
I think so, because I mean the first program I did for the second project, it was like I made an IO command.
Oh, okay.
And then the second one I was gonna like continue to implement that, but with
Mhm.
like with 2 more doors. 'Cause I did with 2 doors just for the first program, and then I wanted to do 2 more doors
Yeah,
for the second program, and then I was thinking of like maybe using the branch to get to get 2 doors each of their own result, and then
yeah.
connect into a final result.
Okay. Yeah, that sounds good. Well, let me just do a poll around the room here. I'm just going to ask a few people to see if they have any comments. Paul, any comments on, or if you want to share a little bit about what you're doing on your Mars MIPS emulator project?
Um, I don't really have much to share right now, to be honest.
Well,
I know we talked about
that's
it in
fine. I'm
class
just
a
trying
little
to get the
bit, but
concept of what you're thinking about and see if I can help out or,
so now we talked about this a little bit on Tuesday, I think, where it was just about like, and I think even last Thursday, it was just a matter of using it to compare sort of like the values of cards, like giving them a certain number and you're like, okay, this is equal, so these are like have this trait in common, for example.
yeah,
Yeah. So that's like
yeah. So these are the kind of things of how you can do is compare if equal, compare if not equal, compare if greater, compare if it's less than, something like that. And so start with something simple. If there's like some dialogue with the console that you want to have, maybe just start with a hello world to get started or something like that, and then start to think of how you're going to compare. That would be good. Okay, thank you, Paul. Um, I'll just arbitrarily a couple other folks. Darian, you want to give us a little heads up on how things are going with your Mars MIP simulator? Some may not be able to chat. You can just put it in, I mean, may not be able to talk. You can just put it into the chat and just let me know. Chantel, you want to give us a little heads up? Thanks, Darian, for responding. So why I'm trying to do this early is I want you to not only just, the night before put together something for an assignment, but thinking about trying to have you have a better intuitive sense of why we're doing what we're doing and how it's going to give you a better understanding of computer architectures. Well, thanks, Chantel. Hopefully you're able to hear us okay, but I know, thank you for some feedback there. Connor, you want to give us some of your thoughts? How's it going for you and your project, or you getting a sense of what you could do with in assembly language programming?
I'm still trying to piece that together as well. I have some ideas floating around, but nothing concrete yet, so I'm just still
Mhm.
thinking about it.
Okay. Well, what's your general project theme? Let's just relate it to that just for a minute or two.
Yeah, so my general project is like smart home devices.
Hmm.
So I was gonna do a sound activated lamp,
Hmm.
and then also do a smart alarm clock. That was the initial idea, but after doing the digital logic design project, I realized that might be harder um, to do,
Well,
and I don't think I'll have the components for that necessarily with my kit because I have a Arduino kit already, but
mhm.
there's a lot of components that I think that I might need that I think I would have to order.
Well, let's just I'll just play on that a little bit here, because this is where another thing that you can be thinking about. Are you going to implement a certain sub-function in hardware or in software? So here is an example in the Mars MIPS emulator where you're counting. So you could you could have a counter that you count up to 100, depending on how fast the clock is, and then you could be reporting a value. So an alarm clock, it could be some kind of arbitrary thing. Remember, a CPU for counting, it's going to be related to what is the CPU clock frequency. And so maybe that clock is in gigahertz, 2 gigahertz or something like that. And so the first step would just be getting something out there. Maybe it's not calibrated. So, but that just gives you an idea. How much are you going to actually do in the hardware versus how much you're going to be doing in the software? So for what I'm showing here, this is giving you a chance to be seeing the hardware in the Arduino, but we also see that this is actually a fairly simple hardware implementation, but it actually takes some more code to do it on the cyber side. And so maybe that might help you as you're trading back and forth what you think you might want to be doing. Does that make sense?
Yeah, it does. Thank you.
And so one other thing that I can point out that it sounds like you, I forgot how you're going to be causing that light to turn on. But since this is one that comes in pretty much most kits, look at this this light sensor. Yeah, this photoconductive cells. So you can actually have a detector that goes when it's either high luminosity and low luminosity, and you can very clearly be getting a chance to what that would look like with your Arduino kit. And I'll show this in a couple weeks, but we're still kind of right in the middle of our Mars MIPS. We haven't quite got there yet. And so that's maybe something that you might want to be thinking about for the automated light. Okay. Does that help a little bit, Connor?
Oh, it does. Thank you.
Good. Freddie, you want to give us a little bit of a heads up on your project, and maybe we can think of how stuff that we're doing with both our assembly language and our Arduino kits might help you to flesh that out? Okay, well, Freddie, it sounds like what I was just conveying to Connor. Hopefully you were tracking with what I said with a couple ideas. Does that make sense? Were you able to follow that? Or if you want me to go over a part of that in more detail, please let me know. Okay, good. That's exactly what I wanted to do is I want to help. And so we're trying to have a couple of different modalities for learning in this course. And so I'm happy to continue to facilitate that as we go. Just one more for today. Grace, you want to give us a heads up on how things are going? Any things you want us to play out with a little bit more in our time together for your project? Okay, I think we could be having some connectivity issues with a couple of folks, and so since Grace isn't able to go off mute or share, I'll just ping one other person. Isaiah, you want to give us a heads up? I think you've already given us a little bit of sense of what you're thinking, but feel free to maybe put it in terms of the context of both for you and others. what it might be with our Mars MIPS emulator or our Arduino kit?
I'm honestly pretty much on the same page as everyone else. I'm kind of just trying to piece everything together and also just learn the code a little better just because it's kind of fresh to me, like the assembly language. But yeah.
Yeah, so I totally understand that, Isaiah. It's getting more common that people have little, if no, experience with assembly language. And so just having something fairly simple like this, hello world, just have something that you can say, okay, I got a program that actually worked. And then starting to relate it to your project. And so if you just give me one idea, one function that's key to your project, I can start to play that out a little bit for you here. While we still have some time in class today, you want to just feed me a little bit of info and I'll see what I can do to help.
Yeah, so one component is just the motors reacting to the buttons that I press. So, left, right, up, down, functions like that. I think that would be a good place to start.
Yeah, well, since I have the Mars MIP open, one of the ways that you can be mimicking that instead of, so let's see if I compile this. And then if I run it, and so here's we enter A, so 5, enter B, 6, and then it does it sums those together. So you might want to be doing something with I/O, and so you have left, right, up, down, and so now you're getting a chance to see how the microcontroller, what's going to be in your Arduino unit, how it's taking information, the CPU or the microcontroller has to be reading information from registers, interpret what that means, and what you're going to actually try and accomplish. And so loading information into registers and then saying, okay, you had a command that you want to go left, right, up, down. So maybe L, R, U, and P, U and D, whatever you want to use. And so then it could just say, okay, I got that. And then it responds, okay, I'm going to command the unit to go left or right by 5 steps. And so maybe you send him another right and says, okay, now I've gone 5 more. So now the total is 10. And so you can have then you need to have a register that's storing how far you've gone in one direction or the other. So that might be something that what you could be doing with your Mars MIPS emulator. Does that make sense, Isaiah?
Yes, thank you.
Yeah, and make it simple. Maybe maybe in the beginning you don't have all 4, you just have one. And just think of how I could translate that to storing information in registers, adding to that, subtracting to that. So here we see an addition of 2 numbers. We get that. We had another one where we have a more of like a counter function. You could be doing something like that. But for your case, well, actually, maybe that might be something you would want to have. And so maybe it says, okay, you're going to go left and you want to go to the whole excursion. And so that would be another part of that commanding scenario that you would have, or you just go a certain number. So those would be some possibilities. Okay. I'm curious to see how much I know you showed that video, and so maybe you've got a handle on how you're actually going to put that all together with your Arduino kit, and that would be a real fun thing, and I'll look forward to see that. But as I've tried to mention to others, there are 3 sub-projects in the Arduino, so start simple. Not that whole thing, get something that it works. And I always like to have people go from success, something that's working, to a more capable, now having that work and just go a little bit at a time. That's the reason why I try to have 3 incremental steps in each one of the sub projects. And so I recommend you give that a think about that as well. Does that help, Isaiah?
Yes, thank you.
Okay. So any other comments or questions that people have? Anything you all want me to go over in a little bit more detail? Okay, well, I hope you guys have a good rest of your day. I'll look forward to seeing you all next Tuesday. Take care now.
Thank you, Professor.
Bye-bye now.
Have a good day.